is that the easiest way to work with these things is to know how to work with perfect squares. Perfect cubes, perfect squares. So when I look at it this way, a lot of times we're going to relate these things back to like square tables. And these are things that you should know off the top of your head. Remember, when we set these things up, if you had y equals x squared, you pick an x that generates the y. You agree? So if you square it, what's 0 squared?
0.
So it's 0. What's 1 squared?
1.
What's 2 squared?
4.
What's 3 squared?
9.
Okay. It works through like that. When you work through with the cubes, we did some of these as well. What's 0 cubed?
0.
What's 1 cubed?
1.
What's 2 cubed?
8.
What's 3 cubed?
27.
What's 4 cubed?
64.
Good. And after that, we kind of stop. So, well, yeah, we did 5. It wasn't that bad, but for all intents and purposes, we're kind of okay with this. So when we start to work with the graphing of these, we start looking at the graphs of just square roots. Eventually, we're going to take and work with the graphs of the square roots and the cube roots, and we're going to shift them as well. But I want to relate it to just something very simple to start with. So if I'm looking at just the graph of y equals the square root of x, when you first learned how to graph things, you picked numbers. You picked values to plot. You made your lives easier. You did that with linear expressions a long time ago, slope-intercept form. You pick, -2, -1, 0, 1, and 2. You'd plot them and see where the line went. You basically are going to do the same exact thing here, but with square roots. So you want to pick values of x that make sense, okay? Because you won't use your calculator for this, just like we've done in the past. This is basically a whole non-calculator style chapter. Yeah, I know. So if I'm starting out with something like this, if I wanted to look at a graph of the square root of x, I'm going to pick values of x that make sense, like 0. What's the square root of 0? 0. What's the square root of 1?
1.
So these are my x's, these are my y's. And I'm substituting in to take the square root of that to figure out this. What's the next value I'm going to pick for x?
4.
Good. Square root of 4 gives me 2. Square root of 9 gives me 3. And so on. We okay with that?
Yeah.
Now, will I be able to pick any negative values here?
No.
And why?
Unreal.
Yeah, we're not dealing with any imaginary stuff. So when I go to graph this, we start walking through, we go through at 0, 0, 1 and 1. Then we're at 4 and 2, 9 and 3.
So it's keeping that one problem.
What was that? I'm sorry?
Is it going to be in louder than this?
Not really.
Wait, will we use
Is that like
calculators
really
with
all there is?
finals, or will
Yeah,
we-
we'll get to that.
Okay.
I'm sorry, go ahead. What were you saying? You're worried that it's going to get more difficult than this.
Yeah.
Okay, well, we're just starting. So.
Not that.
Yeah.
And that's kind of what you're getting into?
That's bringing right there.
Yeah. You know me. And your curve kind of looks like this. And it goes on and on and on.
Yeah.
Now, let me ask you this. What's your domain?
The x.
Correct. What is the domain of this problem? I'll give you that.
I don't know.
All right.
Except 1 through
Is it all real?
It's not going to be all real. Why won't it be all real?
Because
Because they're like
So it's going to be all values of x that are greater than or equal to
1.
0.
Oh.
Because we started at 0. I can start at 0 here. So my domain for this is going to be all x greater than or equal to 0. All right. Yes, ma'am. In this, excuse me. In this case, since it's just saying square root of x, it's not saying plus minus square root. We're just looking at the top half. If it does say that, that means we're going to have an a value out front, and eventually we will get to that. Good question. All right. Now we do the same basic idea then when we look at the cube root. So when I look at a cube root function, again, I'm going to pick values of x that make sense. For example, 0. 0 works, right?
Yeah.
0 worked. What was the cube root of 0?
0.
0. What's the cube root of 1?
1.
Cube root of 8.
2.
I don't want to get any larger than that for right now, just because it's just going to make the graph kind of silly. But think about this. Can I do negative values here?
Yeah.
I can. And I can take negative nth roots because of odd. Excuse me. I can take the odd nth root of a negative, and it's okay because you can do the plus minus here. So I'm also going to choose negative 1 and negative 8. Because what's the cube root then of negative 1?
Negative 1.
Negative 1 and then negative 2. Does that make sense?
Yes.
When I have a cube root, I can have negative values. It's okay. Square root, can't. So then I go to plot it to get a rough idea of what it looks like. So let's see, we had 0, 0, 1 and 1, which was also negative 1 and 1, 8 and 2, negative 8. And this one's kind of doing this. Kind of does that. Okay. Oh, that's awful looking.
These look pretty cool.
Okay. That's the generic look of a cube root function. What's the domain of this one then? This one will be all real. Okay. The domain here is going to be all real. Not too bad? Now, yes, sir.
Will the odd ones always be all real?
Yeah. He's talking about odd nth root. Because you can take the square roots of, or the nth root of an odd value of a negative. So now when you get into this, you do your shift. And we've had A, H, and K in the past when we're looking at graphs. A, H, and K still has kind of the same idea. There's a horizontal and a vertical shift. The A value is the, lack of a better term, an amplitude. It's almost like a slope, how high up or how skinny the graph might look like. We deal a lot with the A value when we get to trig. There's going to be two generic ways of doing this. If I'm looking at the equation of a square root function with an A, H, and K, all you're going to do is the following. Let's say we have y equals 2 square root of x minus 2 plus 3. A lot of times what they're going to do is they're going to put that plus 3 in front. They're going to write it like this. And why do you think they would do that?
So you know this is
Yeah. Just so you know, sometimes they'll do something like that. All right. So this is telling me that I'm moving my my graph over 2 and up 3. Now, when I say over 2, am I moving it left or right, do you think?
Right.
Correct.
If it was plus 2,
Correct. Yes, ma'am.
did you get the 2 from the A or the H?
Oh, I probably shouldn't use the 2 again. Let's change that to let's change it to a 4. Is that okay? That way you guys can see the different values. Sorry about that. It was the H I was talking about left and right there.
But if you just like compare.
I just picked random.
Okay.
Yeah, just to kind of quickly show. I didn't even think that would have come out. Yes, ma'am.
What are you talking about? Moving?
Getting there. We just started. Okay. So in the problem like this, we agree that the graph would be shifted right 4 and up 3. You okay with just leaving it like that for right now? Well, here's what happens in order to figure out what it's going to look like. What you do is you take, in order to show, oops, Step number 1, plot. Handwriting is awful.
Wait.
Yours is.
Yeah, it's more so. Yes, ma'am.
Why wouldn't you put -4 for that?
What do you mean?
Like -4 after the x?
Because this is step 1.
I'm so confused.
What I'm going to do here is you're going to take a generic equation, a generic looking graph, the square root of x. You're going to take those values, you're going to plot that, and you're going to shift those points.
Oh. Well,
That's what
why
happens.
didn't you shift it 2? Because isn't it the square root of 4?
No. Roll with me for a second. Okay. Now, in this case here, if I'm looking at my equation of 2 root x minus 4 all plus 3, what's my value of a? 2. Okay. So what I'm going to do here is I'm going to take my equation and I'm going to plot values to generate this. What are the values of x that I'm going to use that make sense?
0.5. 0.
0, 1, and 4. Does that make sense? You can use 9, but you might, I mean, that's fine. We'll use 0, 1, 4, and 9. Okay?
Why is it square? Why is it only 2 like root x?
Because what you're going to do here is you're going to take and we're going to graph what's called a parent function. The parent function is the generic function that you shift. So we start with this generic function, we plot it, and from those ordered pairs that we create, which will be very easy to do, you move them over and up, or down and right, or whatever it might be.
Just with like putting in the certain things for
Yeah.
like 2 root x.
Exactly. So we're going to pick easy numbers. We're going to pick out easy numbers. 0, 1, 2, 1, 4, and 9. Those are going to be my values of x that I'm going to choose. Okay? When I do that, I get 2 times the square root of 0, which is 0. 2 root 1, which is 2. 2 root 4, which is 4. And 2 root 9, which is 6. You okay with that?
Yeah.
That's giving me ordered pairs to plot. That's the parent function. Okay? This parent function then looks like this. 0, 0.
Wait, is this step 2?
No, yeah, we're doing this all right now. We're plotting this parent function.
Step and plot. Uh-oh.
Okay, we're just plotting the parent function. We pick numbers that are very easy to work with, things you can do in your head, hopefully. X is 1, Y was 2. X is 4. Y was 4. 9, 5, 6, 7, 8, 9, and 6. So this parent function looks like that. Parent functions, when you graph them, you generally plot them with a dotted line, because they're the graph that you're going to model off of. It's not the finished product, if you will. It's your sketch. It's your rough draft. It's your outline. I don't know, get this stuff up. Okay? So now you've plotted your stuff, and then the next thing you have to do is step 2. Shift points. So in this case, our shifting, in order to shift these things, we had it written down a second ago. I think it said that we had to go right 4 and up 3. So to each of these points, in this example, we have to go right 4 and up 3. You okay with that? Take this, go right 4 and up 3. Where'd I get that?
Oh, I got
The
it.
H and K came from the original product.
H is actually
So-
Y, right?
Yep. Horizontal, vertical.
Wait, so how do you know like how far it is? How do you know how far it is?
Wait, horizontal.
The H and K. What are the
Oh, the H.
H and K? H is your X. Horizontal, vertical.
I got it.
Thank you.
I'm assuming the horizontal is horizontal.
You're so confused.
I'm not dealing with my screaming children today.
You just said the word.
Did you think I was going to be blonde?
Probably just because
This
it's
is-
long. You don't really
This
see
is-
that. Now we know what
This
you
is-
look like with hair, though.
Just for men.
Is that Ed?
See all the gray. So to each one of these things, all we have to do is just shift them over. This one went over 4, up 3. So what that been?
It's an S, but H is X.
And over and whatever. So now, when I do that, what you're going to wind up looking at here, guys, is on your graphs, you always start with the parent function. The parent function gives you the idea of where things are going to go. And all you have to do is just shift each one of those ordered pairs. A lot of times people find that it's easy to list out your ordered pairs as your parent ordered pairs and then your shifted ordered pairs. Sometimes it's easier just to do that math instead of doing it off the graph. I'll show you how you do that in the next example. Yes, ma'am?
So when you graph it, it doesn't start at 0, it just between arrows and middle.
Correct. Because now this tells me, since this is a square root function, what's now my domain? Correct. X has to be greater than or equal to 4. Because if you choose any other value of x that's less than 4, I'd wind up with a negative root, therefore it wouldn't work. So now, with your shifted function, you're able to tell what the domain is going to be. Yeah.
Why is it plus 4 if it says minus in the middle?
Remember, it's always the opposite sign. It is the value and then the plus the k. That's just how it always works with the h's and k's.
Wait, what?
What's up?
Okay, so I don't really know how to like draw the little alligator mouth thing in which way. So can I just write it out in words?
Let's try to figure it out.
No, I don't know which way is what. Like I don't know which way.
Which way? See, all right. See how it's x values are going to be bigger than 4. So the bigger than 4, that means you want to eat more of those.
Okay.
The alligator wants to eat more. Because alligators
That's
are
how I
hungry.
remember it.
Okay. I'll try to remember that. I thought you meant that you didn't know how to.
So let's look at another one. Let's look at the one with the third root. Let's look at the third root one.
Wait, so we only have those 2 steps?
Basically, that's it.
All right.
I mean, I'm going to show you guys how to do a cube root function a little bit differently. We're going to do this with the ordered pair style. It works for either method. Some students like to list out their ordered pairs first as opposed to plotting first, but you can do either way. Yes, ma'am?
Okay, so on the last one, the example was like x minus 4. So does that mean like you go up 4 and it's, since it says plus 2, you go down 2, or you
Well,
still go up 2?
this is the h value. Remember, this is your a, x minus h plus k.
So yes.
So my h value here would be negative 2.
So it's like the opposite side.
Correct. So this, but remember, horizontal is left and right. H,
But still you have to go like down and yeah, negative 2, right? And so,
I'd have to go left 2,
okay.
down 1. Okay. So, remember, a here is 3, h is negative 2, and k is negative 1. So I know that when I go to shift these things out, it's going to have to go left 2 and down 1. Okay? It's another way of listing out so that we know how to do it later. Yes, ma'am?
What does A do for
Remember, the A value is kind of like your amplitude. It tells you how fast or how low the curve might become. That's all. It's a multiplier, if you want to think of it that way. It's part of it. The reason I'm having you list it for a second, because it's right in front of here, you cannot screw that up. Is when we get to trig, all right, and when we do logarithm stuff, second semester, A value is really kind of an important thing. So the sooner we're able to just quickly identify it, the better off we'll be. Okay. This is a cube root function, which means I'm going to have plus and minus values. You okay with that?
Yeah.
All right. So if I go to start by plotting out here, I'm going to start with my parent function, which is going to be y equals 3 cube root of x. So I'm going to pick values of x that make sense. We know that it worked with -8, -1, 0, 1, and 8. Right? So if I pick those values out, and I substitute in, what I'm doing there is, again, I'm picking perfect cube roots that I can do in my head. And that's just a matter of substituting and simplifying. What's the cube root of -8? -2 times 3.
Positive gateway.
Yeah, yeah. Okay. What's the cube root of -1? What's -1 times 3? This will become 0, 3, and 6. Are we okay with that? All right. So I know then that I have, this time I'm going to do the, I'm still going to plot my parent function here, but I'm going to show you how you can get your new set of ordered pairs by just shifting them, okay? Without walking it on the graph. Some people like it that way, some people don't. You know what? Let's do it with the graph. It might be a little bit easier to show you. You guys want a piece of scrap paper? Want to try it?
Yeah.
Exciting.
No, it's warm in here for one. Look, the temperature has gone up 2 degrees since we've been in here.
I hate it.
71.7.
Make it cold, Mr.
That's the
Murphy.
warmest it's ever been in here. It's too hot. When we came in, it was
You guys want any?
So, now just so you guys get a quick idea of what it's going to look like. As you go through this, ordered pairs are easy to work with.
Here you go. No, thank you. I'm good. I would definitely pass on.
Okay.
I'm sorry.
So my parent function looks like that.
Mr. Murphy, where do you want this wonderful graph paper that you've given us?
So everybody okay with the plot of this, the setup? All right. Now, when I look at this, I know that to each of these ordered pairs, this first set was -8, -6, -1, -3, 0, 0, 1 and 3, and 8 and 6. Those are my 5 ordered pairs for my parent function. To each of those ordered pairs, all I have to do is subtract 2 and subtract 1. Subtract 2 from x, subtract 1 from y. And those become my new ordered pairs. Right? Oh, let's see if I can do this. This is moved out, right? So my new shifted ordered pairs then would be x minus 2, comma, y minus 1. So what's -8 minus 2? What's -6 minus 1? So this would be at -10, -7, -3, -4, -2, -1, -1, 2, 6, and 5. Everybody see what I did there? It's just a matter of listing out the ordered pairs prior to plotting them. Some people find that it's easier to do it that way as opposed to just trying to walk everything through on the graph. Okay? To be honest with you, I think this way is easier myself. Yes, ma'am?
So up and right are adding and down and left or
It's not just up and right or down and left. Remember, each H value could go left or right, K could go up or down. It depends on the sign of the H, sign of the Y. You can go left and you can go up. You can go right and go down. Depends on the H and the K. If H is positive, it moves right. If H is negative, it moves left. All right, so there's different variations of that depending upon the H's and the
So
K's.
if H and K are positive, it would be right and left.
Correct. So as you go through this, then it's just a matter of replotting then. Oh, negative 10 is. Down 1 over 2. 2. And then when you draw your parent, or your, excuse me, your shifted function, that's when it becomes a solid line. Yes, ma'am?
So you draw both of them, like on all markers?
Yeah.
Okay.
Yep. Not so scary, is it?
It's all right. I'll probably mess it up, though.
I doubt it, but I bet you can tell me what my domain is for this.
Wait.
All real.
All real. All of them are real.
They are all real, yes, all of them.
So we have to do the dotted part first?
Yeah. I know, trust me, there's a reason why I want you guys to get in the habit of doing parent functions. When we do sines and cosines and logarithms and all that, it's so much easier to go off the parent function. I know these aren't tough. I know that you could probably pick out ordered pairs and just be done with it, which is fine. The reason that I'm having you guys do a little bit more of the work is that eventually you're going to be doing stuff like this.
Oh,
I don't like this.
Oh, yeah.
I forgot it.
Okay? You're eventually going to graph something like that.
Oh,
As in
I don't think so.
Yeah. And
What's that squiggle above
Hi. And the reason that I'm trying to get you guys, I know, I totally understand that you guys could probably pick ordered pairs and plot that and be done with it. When you get into more complex scenario graphing of functions, your life is so much easier when you do parent to shift. It's just a lot cleaner. Okay? All the fun stuff we get to look forward to. All right, take a minute and do this one. You guys have been try it on your own. At this point, some of you guys have gone through there. You might have recognized that your A value in this case is negative. So if it's a negative A value, it's going the other direction. So instead of increasing going from left to right, it's decreasing going from left to right. Did you notice that?
Yeah.
Your H value is 7, your K value is -4. Which means my shift will be X plus 7, Y minus 4. That would be my shift after my parent values. Okay? You're going to always pick very easy parent values to work with. -8, -1, 0, 1, and 8. You substitute into your -3 times the cube root, and so on, all the way down. Oops. Now you'll notice that in this case, when you take the cube root of -8, you get -2. -2 times -3 becomes +6. So it just flips itself around then. This will be at +6. This one would have been at +3, 0. Then it goes negative. Okay? So hopefully you got those values for your original parent. 1, 3. Kind of a weird image of the problem we just did. With parent functions, are they solid or dotted?
Got it.
Dotted. I wonder if this will work. So happy sometimes. And then my shifted ordered pairs then. That'll be -1 and 2. 6, -1. 7, -4. 8, -7. 15, -8. All right, I understand that 15 and -8 probably won't fit on your graph. Is it the end of the world?
Yeah.
Yes.
But you feel fine? Thank you. Took a second. That's great. What's up?
15 and -10.
Will be -10.
I'm really good.
I was just checking to make sure you guys were adding and subtracting correctly after, so much time away. And if you believe that, I have an island to sell you.
I was gonna say, what? I was confused for a second, going over that.
Good times. So let's see, this becomes -1, 2, 6, -1, 7, -4, 8, -7.
Do you think this favor is more into like?
And then -15 and something like that.
Oh, I read it as.
Oops.
You got to.
Yes, your shift will always be solid. The parent is dotted.
It looks like
Was that like shut the door in
DNA.
front?
What's your domain now? What's that? It's all really because it's continuous. There's no break. When you have kind of a dead giveaway, since this is an odd entry, you're getting all the entry. When it's a square root, you have to worry about what your stop is. Okay, not so bad. Let me give you a few of these to try out for tonight.
A few more like 15. That's what yeah, that's what it always is.
West
So we're not gonna do any.
I gotta like.
He spent the first paragraph.
Okay, Mike, so that book, and you wrote Mike, and everyone sort of loved it, and then stop.
Yep, blue lessons. Make sure when you're graphing these, you graph them with parent function. List out your ordered pairs like we were doing. Shifted function, and list out your ordered pairs of your shift, please. Don't forget domain.
We don't have to do range.
You can do range too, yeah. It's not, domain and range, if you go back and you look at the one we just did, your domain and range and that one's to be all real number, okay? Your range for your square roots is gonna, when it's just a regular square root, will depend on that one. Let me just real quickly show you here. I'll put this back up in a second, guys. Let me go back to the square root one we did at the beginning. In this problem, we first looked at the square root, you guys told me my domain. I'll go back to it in a minute. We said that the domain here was all values greater than or equal to 4. Or excuse, yeah, for x values. What would be the range then for this?
All?
It's going to be all y values greater than or equal to 3. So what happens here is that you're going to be working with the, how do we say, the starting point of the graph. that's gonna be the telltale of where your domain and range are gonna go off of on square roots when you go to the shifted starting point. Yes, sir?
So do you have to state the domain and range?
Yeah,
Okay.
I just didn't do the range because pretty easy stuff. Alright. Yeah, I was gonna put it up on the door.